Yeah, just when now actually before critical angle I had to tell you, I had to told you this thing. Here, the real and apparent depth. Actually, when you see any object below a certain denser medium, not exactly normally, then it appears at lesser depth than actual depth. Like if you see the bottom of bucket filled of water, normally that appears at the same place, but if you make your eye little away from normal, that bottom appear raised above this. So that is called apparent depth. Here in this figure it is a glass slab whose actual height thickness is h, and here is some point object placed below this, which is being seen by this eye. Actually, light falls from somewhere on this, and after reflection, it goes back here and gets refracted. This is the angle of incidence here. This, and when light goes from denser to rarer, it bend away from normal. तो ये थोड़ा refraction हुआ, angle R greater than angle I. When we produce back, it meets at point A dash. So point A appears at A dash. So this BC, A dash B, will be the apparent depth H dash, लिखा मैं इसको H dash. Now, if this angle I, so this is also I. This R, so this is also R. This approximation close to normal के लिए true है. It is true for close to normal incidence. So now it is clear, it is a glass slab. Point A is placed on paper below the glass slab. It is seen by the eye, it appears at point A dash. Or if you put some coin in water or any liquid, transparent liquid, appears at less depth. So now we try to establish here the relation between apparent depth and real depth and index. Here in triangle ABC, in triangle ABC, sin I is equal to perpendicular hypotenuse. Perpendicular is BC, hypotenuse AC, BC upon AC. Sin R, BC upon A dash C. If angle I and R are small, then AC is nearly close to AB and A dash C also close to A dash B, and hence sin I is equal to BC upon AB, and sin R is equal to BC upon A dash B. And hence sin I upon sin R here. And hence sin I upon sin R. BC upon A dash AB upon BC upon A dash B. This cancel. So sin I upon sin R is equal to A dash B upon AB. But from Snell's law, here sin I upon sin R for this point, sin I upon sin R is equal to 1 upon n. The light going from glass to air, and therefore 1 upon n is equal to n का है index A dash B upon AB, or n dash is equal to, or n equal to AB upon A dash B. Then you can H upon H dash equal to real depth upon apparent depth. Or you can say here that H dash is equal to H upon N. H upon N. इनके इंडेक्स मोर देन 1 होगा तो H less than H, apparent depth will less than actual depth. So how much is this shift A dash? Actually it is A dash B. H dash means A dash B. So apparent shift is equal to H minus H dash, यानी कि H minus H upon N. So it is H common 1 minus H upon 1 upon N. Some author use mu in place of N, mu, that is index. But our NCERT book using N, so I am following that. Now, this is one thing here. It is true only when we are close, our point C close to B. Angle I and angle R very small. It is only true. Now, question come other way. Yesterday I was observing a paper, test paper from some coaching center. So if here we have a container and different liquids, suppose height H1, index N1, height H2, H2, index N2, and this is H3 or index N3. तो जैसे पॉइंट बी यहाँ था हमारा, अब ये ए डैश कहीं यहाँ आएगा अगर मान लो एक जगह, तो व्हाट इज अपरेंट डेप्थ, यानी कि व्हाट इज ए डैश बी, दैट विल सिंपली H1 upon N1 plus H2 upon N2 plus H3 upon N3. And then how much is A dash? Apparent shift. Generally apparent shift पूछते हैं एग्जाम में लोग बाग. These are three immiscible liquid of index N1, N2, N3. तो एक्चुअली A dash जो है apparent shift जो बोलते हैं, apparent sit. वो तो एक किस्म से ए बी मतलब फिर वो कहते हैं एच है और ए डैश बी अगेन एच डैश अपेरेंट, तो सिट इज एच माइनस एच डैश, यानी कि ए बी माइनस ए डैश बी, लेट ए बी इक्वल टू एच, तो इट इज एच माइनस है भाई, एच माइनस क्या, कुछ गड़बड़ हो गया। ठीक है, एच माइनस सी तो होगा ना, तो इट विल बी H1 upon N1 plus H2 upon N2 plus H3 upon N3. So you can use this directly. H is a total thickness, actual height H. So we get, this was question there in that paper. The 3 immiscible liquid or 2 immiscible liquid, how much the apparent? So you can directly use this thing. You can use directly this thing to get paper solved easily. So this was all about apparent depth and real depth. So now I will be telling you many questions in coming videos. So please keep on revising. It will be simple for you to understand the questions.